सर आवाज आ रही है?
हाँ, yes sir, yes.
Okay sir, okay. So shall we start, sir?
Please. Actually, here little bandwidth low. I'll turn off my video after some time. Maybe.
Yes. Okay sir, sure. So welcome you, sir, in this online FDP on smart grid, smart technologies and communication protocol in power system. Let me cite the brief biography of Dr. R.K. Behra, sir. So, Ranjan Kumar Behra, sir, received the Bachelor Engineering degree in Electrical Engineering from the Regional Engineering College, now NIT Rourkela, India, and the MTech and PhD degree from Indian Institute of Technology, Kanpur, India, in 1998, 2003, and 2009, respectively. He worked at Hindustan Aeronautic Limited, Shona Beda, as a trainee engineer. Since May 2009, he is the faculty member in the Department of Electrical Engineering at IIT Patna, where he became head of department in January 2016 to 31st March 2019. During July 2008 to Feb 2009, he was a visiting scholar in the Energy System Research Center, TNS Technological University, USA, and also as a visiting research collaborator at ECE Department, University of Pretoria, South Africa during July 2016. He got several national and international awards, such as Young Scientist Award in Engineering Science from DST, Government of India 2001, selected as the Feature Engineer of the Globe 2015, USA, and Bhaskara Advanced Solar Energy Award, Indo-US Science and Technology Forum 2014 for doing solar research in Energy System Research Center, TNS Technological University, USA. He published more than 100 research articles in different national, international journal and conference proceedings. His research area interests include power electronic, high power drives, smart grid and IoT applications. He is co-authored a book entitled Power Electronic Drives and Advanced Applications, CRC Press. So once again, I welcome you, sir, and I request you to kindly start your presentation.
Okay. So, sir, I am very sorry for it. I don't know. Morning I tested, it was working fine. And now it is very difficult to connect and download anything here. So again, I have to change over to mobile to here and there. So sorry for
No
delay.
problem, sir. No problem. It's okay.
Okay. So today I'll speak about the microgrid topology, architecture, and design. I am very thankful to Dr. Vijay Pratap sir, where last time also he invited. I gave a talk on story of IoT. And now I will give a little bit of application of that one, where we implemented many projects throughout India as well as abroad also. And those projects I will discuss here. And what is current project also, mainly we work on microgrid, smart microgrid architecture and design. So we design starting from planning stage, then commissioning, then after utilization testing, and then supplying also. These four things we do. And we also develop many kinds of products actually. Now we have developed a product for emergency power supply, a tiny microgrid, which is nearly 1.6 kilowatt. And it will have a horizontal wind turbine and vertical wind turbine, what you can see in the screen, and a solar system with a portable battery and connecting any place. In Bihar, there are a lot of flood, and that flood can be actually during that period, it is very difficult to get any power supplies. So this system will give you the all kinds of facilities to give power supply during the emergency condition. So with this, so we develop many products. Anybody, you can also visit our lab where we have all kinds of hardware setup, and different people from NIT, Jamshedpur, NIT Patna, NIT Meghalaya, and some from SRM University, they also come here to do some research actually on energy system. And that is what I invite everyone to visit if you have time after COVID. So this is what Sir already told about the journey, how I travel in different places. Mainly today we are working on solar and wind power research mainly, grid integrated. And now we have started working on the smooth integrating with different energy sources with adaptive controller, where you can automatically, it will change the control structure to accommodate different type of power grid. And we work on the power electronics and drives and wireless power also we work. And we work also some topics on the wireless power transfer, smart grid, and EV design. So just now we have also, so sir, you can change the slides. I am in the third slide.
Okay, sir. Okay.
Yes. So this is we design. We design also low cost electric vehicles also. Low cost electric vehicle design also one of the topic we already started this one. And also next slide, sir. So then we do other research activities also. The multi-phase drive for ship engine, electric vehicle, and the LED-based system also we design. And also smart grid we do. So some wireless power transfer system and also some drive system we integrate to this one. And with then you can go, sir, outline next two slide after. Two slide. So the outline is that the cyber physical system based distributed system will try to analyze few of things where we implemented in IIT Patna a complete network system. And so this the grid infrastructure we control, and then nanogrid monitoring system we will see, and then high volt the HEV, or you will see that in the IIT Patna campus, and then we will see some the rural electrification and IoT based smart transmission system, which is we have developed in the practical in the lab. So sir, next slide. Next again. Yes. So these are the villages connected to IIT Patna. And we got around 1 megawatt solar plant, and I'll show end up this one, how we implemented this one. And this solar, this you can see that there is a grid integrated system, and grid integrated system and a photovoltaic system. And there are also 2-3 villages we have connected, because in the Behra you will find in villages, the power scenario is very bad. And to cater this power scenario, so IIT Patna and with the Association of Ministry of HRD, we have started another plan of providing the power supplies to the power supplies to different villages. So that is why we want to create the network. And you can see here, there are different power circuits and there is a control circuit. And this yellow color one is our control circuit, and this circuit is our black color is our power network. And these two networks are connected, integrated together. And this is, you can go next slide. So the multi-layer control system, if you see here, generally today, if you design a solar system or a wind system, these systems are integrated together with the intelligent system. If this intelligent system is not connected to this one, then always you will find there are many difficulties in analyzing. Nowadays, people have already learned how to integrate a solar energy to the grid or how to utilize a solar energy, and everything is integrated together actually. But today, the most important thing, the power engineers, they must integrate all these smart things into that device. And then only you can have some innovation into that. For example, you want a user interface. How a user can interface with you is a very important thing, because they have a demand, and you will see the energy market, whether availability, and there are so many, there are also net metering, and these are the very important issue. And like we have designed for a Bombay, for a RRR district, we designed a solar battery charging system for small the electric vehicles, 3-wheelers. So it is around 1.6 kilowatt. So 5 electric vehicle can be charged together once. So you don't know these drivers, they have no knowledge about this one. And you need to they will bring their charger and reconnect to your system, that's all. And that is what the charger will be connected to the system, and the system will interface with this charger. And how they have no knowledge about this. So they will come, they will put their charger at a 5 charger at a time. So what they will do, they will just enter, their one code is given, and then the code they will enter, then the charger will open. That means charger will connect, charger will supply from the charging station. So this is a basic thing we have designed, but now we are designing how to measure how much, for example, 1 hour charging. 1 hour charging, 32 rupees. That they must get in their bill. Okay, if 1 hour they are charging 32 rupees, because it is a rural village, so they will not give so much. Also, while charging, some customer they may call, please come, we have to go. So they will leave that one. So that time recording is, if they used half an hour, that recording, plus if they will they will come half an hour, both they will add together and get a bill of 32 rupees. So like that, this interfacing is a biggest thing today. And then forecasting, management, and control. And if you see here, you see we need to integrate the machine learning framework, because many times we have many events. For example, Prime Minister come to Patna, so they required around 2.6 megawatt of the power. So that megawatt of power, they must be catered from different places nearby. So this much power must be cut from other villages. So like that events, then we have, you can normalize the dynamic, the machine learning framework, then load requirement area-wise prediction. What is this area? We will get the load, how much this area required. So important loads we can find out. And grid infrastructure, whether you will bring the power from Ara, or you will bring from Patna, or you will bring from Boxer. The different grid structures. So which grid you will supply when the power is unable from one grid. And optimal load forecasting is another condition where one of our students is working, that optimal load forecasting is another big aspect of study by using machine learning technique. And failure prediction and warning are the another kind of the network. So if you see next slide. So in IIT Patna, that is how when we supply to different villages, and we see online monitoring unit where the power supplies are catered from the online monitoring unit. And these online monitoring are taken place, and we have put all the places our smart energy meter where they give us this data where you can predict after 1 year, or where there is some kind of forecasting we can do. So next, so to cater all these things, so we need innovation in sustainable energy required. Okay, so already energy is there. How we innovate? It's not that DC was not there. DC was there since a long time. When Edison was invented in 1884, the DC, when he started glowing the lamp, first incandescent lamp, then you will find that became very popular during that period. And after that, in 1894, when first AC alternating high transmission system was started from Leofen, from the Frankfurt to Leofen, which is 110 miles. And after that, people became astonished that the power can be transferred from such a long distance, 110 miles. It was only around 150 hertz, 133 hertz system, and power could able to transmit such a long distance, and people became astonished with the AC. And then AC became it was shown in those period in the electrical first international electrical expos. It was shown, and subsequently this became the lifeline of completely all over the world. People, they became very happy, and they wanted to. Everybody want in New York City. I was just reading that Nikola Tesla, and when they started, when Thomas Edison started, and every day 1,000 applications will come to him, and to give a power supply. Although it was dangerous that time because bare conductor, there was no insulation, and sometimes if anybody will touch it, they get heavy shock. So grounding was also another difficulty those period. But still, because the light was there, like initially, the mobile came like Nokia, and those periods, small, the big mobile, still people has so much craze actually to get that everything. So that is how this microgrid, this DC and AC, and then when this Tesla saw that, yes, we can do best, we can make very good, we can make very beautiful long line transmission system with very white lights, and that becomes very popular. So that is how all this AC, DC, microgrid, everything can be improved. So what will be the structure of microgrid? If you see, nowadays the government is giving subsidies, and 20 to 35% of the energy should be renewable energy, and distributed generation, net metering, and storage, and time dynamic pricing, which is not there in India, because in India we all get government power supplies only. And then the energy management is the most important thing today, and plug-in hybrid vehicle and sensor and automated control, which is coming a big way actually. All over the world, the sensors are now growing and growing. Now we have more than 38 sensors are available today, till today, and these sensors we can use. Okay, sir. Next slide. So microgrid is the distribution of this distributed energy, and there are different kind of microgrid, mini grid, and then there are nano grids also. And in IIT Kanpur, Dr. Shantanu Mishra, and he worked more on nano grid, and you can see that the grids were very small, and they tested many type of topologies. Although it is not in the practice, but in the lab they have developed many topologies and nanogrid. And seeing this one, we also developed a few topologies for one of the villages, not one village, one district, Araria district. In the Araria district, we developed this complete nanogrid, and we supplied a long way. And that also we will discuss this one. Okay, next slide, sir. So then if you see the microgrid generation, that means you generate in one place and consume. For example, in IIT Patna, we have 1 megawatt. So we distributed in different buildings. So locally generated and locally utilized system we use there, where that is completely locally it is generated and locally it is utilized, the system. And when it is locally generated and locally used, then we need some kind of management system, and that management system must be completely free from, or security must be added to this one, because anybody can come and change your password, so it will affect the system. So next slide, sir. So then if you see microgrid operational goal, there are many, the stabilization, spanning reserve, which is very important, and then smoothing, saving, and shifting, and spanning reservoir is one of the biggest thing actually today. For example, when we have a conventional power plant, the big, if you go to any thermal power plant, for example, or you go to the hydroelectric power station, they are connected with a very large flywheel, and this flywheel stores the kinetic energy. So it stores the energy in the form of kinetic energy, and as soon as there are peak loads, it will supply. Whereas in our microgrid or renewable energy-based system, these are not possible to give actually. How it is not possible? Because as soon as there is a peak demand, you need to have some kind of storage, then only you can supply. So peak demand is not on, and you cannot predict that you will get always the solar or wind power. So with this, so next slide. So there are many problems. One is price stability. There are many problems can be solved by using distributed. Is the price? These are all one PhD topic. If anybody want to study, and they can easily do PhD. One of the topics. First one is the price stability, and Dr. Srivastava, in IIT Kanpur, Dr. S.C. Srivastava is a king in the price and marketing, all these things, in IIT Kanpur, and reliability of electricity and electrical efficiency. Security is another aspect today coming into because of the smart grid, self-healing and security. A power supply is another kind of, and environmental conservation and scalability. So challenges, there are many challenges actually. One is scheduling, congestion and compliance, and trading, risk management and market solution. So next slide, sir. So this one, is if we see this transmission, if you see, there are a lot of challenges when you integrate with the grid. And I will tell you in the end of this, maybe in the end of this slide, we have implemented just a few days back, not a few, last year, that one complete design. We started from designing the structural design also for a solar power plant in the Port Blair Airport Station. It's 1 megawatt. In Port Blair, there was some problems. What is the problem? First thing is, because it is a sandy. So in the sands are there, so any structure you put, the structure will not have any stability. So because the structural stability is not there, after some time, these structures may start vibrating. And second one, when you put a solar panel, there are heavy wind. When this wind blows, they carries these sand particles, which strike on the solar panel, which damage the microelectronic structure of that panel. Outside you are seeing the panel is very nice, it is very good, and you must be thinking the efficiencies, whatever the company set efficiency you get, but actually you will never get that one. So why? Because of the sand particles strike under the panel, that will create a microelectronics leakage between, and that is what when you design, you will find it's a very complicated system. Okay, next. So there are many different classification of microgrid, and I am not going to next slide, sir. So then these classifications are there where we can go from less than 2 megawatt up to mini micro size also. So, sir, another 2 slide. Can you move? Another slide. I have already discussed. Yes. There are 2 structures of microgrid where you have a AC microgrid and DC microgrid. And AC microgrid is very popular, you know also. Whereas DC microgrid, next slide, DC microgrid, if you go, I have visited one of the DC microgrid, and which is around 10 megawatt microgrid structure in, so next slide. And this is, so and this microgrid, DC microgrid, I have seen in one of this DC microgrid in California, in Microsoft Office, if you go, there are around 16,000 employees. In the 16,000 employees, everybody has a laptop, but nobody have a charger because they have completely solar in one of the top of the hill. Their office is there. In that office, they have completely solar plated. And from the solar, they get different kind of bus structure. The DC bus is, for example, if you have a Dell laptop, it is required 13.6 volt. So they have a 13.6 volt bus. You just go and touch it, and you will get the power supplies. And that is how this complete unit will be carried out. And this DC microgrid system is already utilized. And they have, if you want to increase that voltage also, there is a knob by which you can increase or decrease the voltage, DC link voltage. And that way, the complete plant, if you see that complete Microsoft Office, is very beautifully designed, and they have only DC distribution for lighting, for the computers, everything, because computer you require a DC power supply from a charger. So that is what they are avoiding the chargers at all. Then next. So there are many. We are in that one village. We are implementing this structure that power sharing among the consumers. For example, you have one house and you produce 5 kilowatt, and next house For example, he has also 5 kilowatt, but he required 10 kilowatt. So he can take your house power without taking from the grid. And that is called the local sharing and local utilization. And for that, you need a prediction layer. And then you need some kind of estimation algorithm where you estimate that this house required today 10 kilowatt and this house has a surplus. So it is a less low loss line, so we can transfer that much of power. So this type of renewable energy integration are now is going on, and many places people are thinking that it will go. So next slide, sir. Then we have a different AC microgrids. You know that there are grid forming, okay, where there is no parallel inverter can be connected here, and sometimes grid feeding according to require the power and the reactive active power demand. Then we have a current source based grid supporting system, and then voltage source. So we know all these things. So next. So then next, this is a smart DC nanogrid, which we designed for one of the village is Araria, where we have a control unit and a monitoring unit. Control unit is a power sharing, closed loop voltage control. And monitoring unit is a home server, energy management, and communication unit. So this description, this control unit and monitoring unit, we designed in a small scale, then we implemented. So next slide. So this is a very simple system. We have so next slide, sir. So we have a solar PV, and then we have a simple converter unit and connecting to a DC bus. And from DC bus, we are connecting to the load. And from DC bus, we are connecting to a battery. And then we have a low cost communication unit where you can connect. For example, in that Araria district, the villages are located very remotely. And it is also from Patna, it is 8-hour travel to that place. And after going there, and we put this solar plant and ask our technician to stay there. They told, no, sir, we cannot stay in this village. So they are coming back. So how you will monitor whether the solar plant is working or not? We need to embed it with communication unit, the communication network, so that the information we can get from our place. So with that one, so this communication network was designed, and after this communication network, then we started designing this one. And you can see here there are two control, and this control I am not going detail into modeling other thing. All people they know this modeling. So we have boost and buck converter. Then we connect to the local load as well as the household loads also. So next slide. So the controller, we have three kind of controller which took as a master slave controller. For example, why it is important? Because in communication network, these are the important thing that which one will be connected first. Which will be connected first? You will discharge the battery, or first you will charge the battery. So there are many things are there where while seeing a controller structure. So if you go to next slide. So in the next slide, you can see there is a MPPT plus battery charging mode, and it is a constant voltage charging, the conventional voltage charging and battery charging system, and then MPPT with battery discharging mode. So when you will go for these three kind of controller, you can go for these three kind of controller. When you have it is more than nominal voltage, you can charge the battery and supply to your load. And when it is at the nominal voltage, maybe I am not able to show you the cursor. So you just, I am just trying to explain this one. And when it is nominal voltage, because you want to add machine learning technique, you want to add all the artificial intelligence. So how we can do this? These are the logic-based system where we first analyze, then we go through a flow chart and try to implement. When this is the voltage is lower than that, then the discharging mode comes. And then we have a low speed communication unit, because the villagers, they cannot pay you. They cannot even give 20 rupees per month also, the electricity sometimes. So next slide. So we have a small the communication unit with the MPPT tracking system, and the complete unit we design, because the villagers, they cannot pay us more. So next slide. The load data, if you see in a village, a typical home, we have a this fan and light and some mobile or TV. These are the few things, gadgets, where in the household equipments where we can connect. So if you see, total is 1.150 watt of the power. And with this power prediction, next slide, so we can see what are the load requirement, because this profile, you can also monitor for next year's this same profile. Actually, that is why for prediction, we can see that what is the power demand. Accordingly, you can plan. Okay, planning can be done based on the demand from previous studies. So this is the typical load profile. Then we have converter, next slide. Then we have converter parameters, and these parameters we choose based on the requirement of that village. So next slide. Then we design an online monitoring unit where you can control and monitor by sitting here at IIT Patna. In IIT Patna, you can get all the profile, voltage profile, and because we have a current sensor, voltage sensor, and temperature, and which switch also on, you can understand. So initially we implemented an online monitoring unit. So next slide. And then we put in a small structure there. And next slide. Then we have a complete, you can see that this is the controller. And the next slide, sir. Then we complete unit we tested in the laboratory, what we are going to put in their villages. So we put this, you can see there is a small, around 40 watt hour battery for 4-hour backup also we have provided. And then you can complete unit we designed. Then if you see here in this online portal, you see here solar is green. That means solar is supplying the power, and battery is green, battery also charging. If you can push here, it will become red, means the battery is not charging. Okay, that way. And the port 1 and port 2 are two loads. If the solar is not having sufficient power, or solar is not having sufficient power generation, then you can switch off this port 1 and port 2. Based on the power requirement, you can predict, okay, this, because the solar is producing 2 kilowatt, so both the loads are 1 kilowatt, or the solar is less than 2 kilowatt, you can charge only, or you can turn on only one load, which is very important. Then next is a few results, are how these results are taken. So we are not going in detail into this result. So next. So next result, if you see here, you can see that battery charging, discharging. You can see the battery can charge and battery can also discharge. So when our logic was to increase the lifetime of the battery, because you put in a village and where you don't want to go there, so lifetime must be increased. So how we do? First, we try to supply all power if the load is having full load, and then we should supply all the power to the load. And when there is some no loads, no supplies at all available, we discharge this one. So this way you can take, then next slide, sir. Then we have a similar kind of load. and we have a cost estimation. So another slide, sir, you can change. So next, yes, this is the cost which you will get the smart system with 12,660 rupees. Okay, so these are the different. Then next one, next slide. So if you see here, you can see that the grid voltage, grid is supplying 0, battery is supplying 0, fully solar power is utilized by the load. So this, by connecting this one, you can understand that it takes directly all the solar energy is utilized for this for the. Then next. So if you see when the solar was 0, whole power was supplied by the batteries, and like that. Then next slide. If you see here, next slide, both solar and battery, they are supplying the power. Okay, if you have a 5 kilowatt, the solar is giving 2 kilowatt, another 3 kilowatt you can take from the battery. So this way we design the complete unit, and it is next slide, sir. Then we implemented in one of these 40 unit of 1.2 kilowatt, and this is the Dr. Soren, who stays in the Sweden, and it is his village. So he sponsored us this project, and we go and implement in that village. And the people there, we have put around 40 unit in different place. And although they don't pay anything, and 20 rupees also they cannot pay per month. Okay. So, but we have supplied 2 bulb and 1 fan, and they are very happy. And we put also 3 houses together. So then we have a different microgrid architecture. Here I will show you that how the solar PV and with grid integrated and with power transmission line. So next slide, sir. So in the transmission unit, in the next slide, sir. So in the power transmission unit, if you see here, next slide, here we designed, but I cannot show you today the video. I have in the PPT, I have here in my laptop all the videos how we implemented. And for this one also, we got Grid Tech Award for 2018 in the Power Grid Corporation of India. They have the Ministry of Power, they have a competition to design the smart power distribution network. So we participated for this, and though we got around 40,000 rupees for this project. So this is one of the now we are integrating many things into this one. So this I'll discuss, and we see there are smart meters came into the system. And next slide, sir. So first one, the smart system came into the system that for billing purpose. Initially, they converted from the analog meter to digital meter, and digital meter, then they try to measure how much you consume. That meter can quickly, you can see in the digital meter, you got 4 unit or 10 unit like that. Then they try to get those information into the mobile or in your device. After getting that information, they thought that when we get the information, that means you got the data. Why not connect an actuating device to control that? Then this became the smart system came into picture, and that is what the smart meter and consumers, and that utilizes. And next slide, sir. So that way, the smart today power smart grid come into picture because of the smart metering which is used by European people. Then this one converted today as a smart grid and smart network, smart microgrid, smart nanogrid, so many comes into picture. So we have here the main objective of this project was we have a transmission line. We built a a systematic model of a transmission line, and transmission line is having the long transmission line, short transmission line, and medium transmission line. And according to power, we operate a long transmission. For example, you want to send bulk amount of power. So when bulk amount of power you want to send to the network, then you have a very long transmission system. If you want to send the medium power, then you have a medium, then lower power. For example, here what we have taken if it is 5 kilowatt of power, then long transmission line will operate. If you have a 3 kilowatt of power, medium transmission line will operate. And if we have less than 3 kilowatt, then short transmission line. And that way we model the system. And this microgrid is integrated with other devices. So can you go, sir, and the two slides? Please change another one. Okay. So here, what we did, you can see here, this red color marking are the one of the smart meters. And the smart meter is connected. You have a solar PV system, and connected to, through this smart meter, we connected to this AC grid. And this also, there are many loads through these different distribution transformers. We connected all these red are the smart switches or the smart meters, where each you can monitor each portion of your network, okay, by this way. And you can also predict also, and you can also estimate also. And these are the many, we have only 6 number of the smart meters, and you can have n number of the smart meter and n number of the voltage measuring unit, n number of this one. Then that will come a sensor coordination unit also. That will become another kind of problem actually in the network. So if you see today 5G is coming, and because of this one, the people are very much addicted to connect to different loads with smart device. After someday you will see in your house also will have a smart meters, and where you are not in the home, you can just switch off and to disable that switch, and it will disconnect your load, so that the constant consumption of the load due to the leakage current will be minimized. So the meter reading will come lower than that one. So this way, this transformer and load and all these things are connected, and we have connected to a long transmission system. So next slide, sir. So when we have a distributed generation inverter model, then we have this. This is our, you know that droop control method, okay? So droop control method is for a large system, it is very beautiful, beneficial. And parallel load also, if there are 2 inverters supplying the common load also, that is also another kind of challenges, and that way we control this to network. So then we used the proportional and resonant controller. So next slide, sir. So we have a proportional resonant controller where we can use, for example, you have a DC quantity. You can use a PI controller, proportional and integral controller. It will work because your reference is a DC, and you want to control a quantity, whether AC or DC, but your controller is a DC. Okay, actually, so that is what command is DC. So when the command is DC associated with some kind of ripple, which is in form of AC. So the PR controller or resonant controller is one of the important aspect of finding this, solving this kind of the resonant network. And this is where we could design the controller. Please go to next slide. So then we have a closed loop control system, and this closed loop control system you can find out from the border diagram. the magnitude and pause plot both are nearly positive, and there is a peak because of there is a resonant controller. Resonant controller means that there must be, and if you have a double band, then you can have. So this complete unit, you can see here, we have, these are the all, I am just trying to explain because I do not have any, I am trying to explain that each you can see there are knobs actually here, black knobs, and these black knobs are there, and these knobs are nothing but one segment of transmission system. So we have a solar unit here through a single phase inverter, and it is a single phase network. And this single phase network, you can see here, there is a inductors are below. You can see below we kept all these inductors, where inductors are treated as line inductances. And this smaller, the black color one is our capacitor unit. Inductor unit and capacitor unit are connected to another, this line, okay? And then through this, each segment is represented the line of 80 kilometers, okay? 80, 140, and then 220. Okay, like that we can, this 80 kilometer line segment, and then we have a capacitor. These are the stray capacitance. You can see in the where this red color the connectors are connected. That is nothing but our stray capacitance. This will behave like a stray capacitance, and these are the line inductances are connected, and this is connected to different kind of loads. And you can see that these are in the CRO, the result, how it is fed to this transmission system. So next slide. If you see here, there are this white color, which is lying on the ground. You can see this white color is smart power meter, and there are smart breakers also, where it can break by controlling by your mobile also. So this is a smart transmission system. You can see the complete unit exactly behave like a transmission system. What are the transmission system behavior? The transmission system behavior means if it is a long transmission system, which is underloaded or very less load is connected, then your receiving end voltage, you will have higher than the sending end voltage, and which is called the Ferranti effect. So that Ferranti effect is here observed, because this exact parameter, it is a model, still you will get the exactly that how this is, this behave exactly like a long transmission system, and this meter are connected according to power. You actuate the device. For example, your solar is having 5 kilowatt, the long transmission line will operate. If it is having 3 kilowatt, medium transmission line, and less than 3 kilowatt, short transmission line will be operated. And this way, next slide. So this way, we implemented the complete unit by feeding from a single phase inverter, because inverter you give a square wave kind of feeding. So what are the effect? Because you have a skin effect, you have a proximity effect, as you have a losses, how it affect on a big transmission system. That is also big study actually. We are now doing that one also. So next slide, please. In the next slide, you can see that this single phase inverter are fed, and when you fed a PWM inverter, you can see from the CRO, there is a square wave actually, and the pulsating the PWM waves. And these waves, when you fed it to this type of long transmission line, and there are a lot of effect actually. First thing is the effect of due to high frequency, it affect on the resonance of the system. So I told you, in the network, when you have a long transmission system, in the network you have a feeding from a solar plant. then there are three kind of frequency associated. One is your sampling frequency, second one is your switching frequency, third one is your resonant frequency. And the complete unit is given here. You can see here our breaker unit. You see here there are this is the our in the mobile app, and in this app you can control your power, you can control all the breakers. You see breaker 2 and 3 are on, breaker 1 is off actually here. And this way these breakers are connected and it can monitor all the powers. You can see here 145.35 watt, and next one when the loads are increased 149.67 watt. And this complete unit we presented also in the Power Tech competition. And they told that they told one comment that if you are just doing for 230 volt, if it is operated at 11 kV, how it will behave. So that we don't know, because it is even now we have developed a three-phase system, and that is just a few days back our student developed a three-phase system, and where we are operating at 440 volt, but it was for working very nice actually. But still there are some problem because of the ringing effect and because of the switching and paralleling of the inverters. There are some problems still there. So we are, that's what I have not put here. And this way we can control this complete unit by your mobile app itself. So next, you can see this is the smart energy meter reading. You can see at what time you get the peak demand, and according to that peak demand, you can supply during that period the peak power. So that means if you have a storage where during peak hour, you can just connect the storage unit so that there will be minimal discharge and charging performance. So there is a minimal discharge means then your system reliability can be improved so much. And this way, if you see these energy meters are very perfectly designed, and then we monitor this one. Then go to next one. And there are also very few AC phase measurement units, also IoT-based energy meters also we use. So next slide. So then we have these are the we can see that this is the smart switches as well as the smart meters are connected. Then next slide. So you can see here the performance during 80 kilometer of the transmission line. You see the 80 kilometer line and the 240 kilometer line. You can see the phase, the magnitude of the voltage. So as the long transmission line, you have more drop in the long transmission line, and you can see that the voltage is shrinking actually. And that is what the behavior of a long end. And when you have an extra load, for example, here in the figure 11, you see suddenly the dynamic loading condition, you increase the load during the evening time, okay? So this, as soon as you increase the load, so that the dynamic comes into this picture. Then you have a grid performance here, you can see here. So next slide. So this is the one of our imprint project where we have. So complete unit is developed. The conclusion, you can go, sir. So the conclusion, because it is treated in the imprint as one of the best projects. So we presented this one to Ministry of HRD. So next, sir. So then conclusion is that we very beautiful design and this hardware. And next two slide. So I am sorry here we have a video, but I cannot show you the video. So
hello. Thank you so much, sir. for giving a very wonderful talk on the design and implementation.
Sir, do I have time or time is over?
Sir, 15 minutes more, sir.
Okay, no. I will stop here. So if they have any
Yes.
questions or comments, I want to hear. Sorry, actually today I could not able to give you many things because of my laptop and this place where I am situated now. So, but many things need to. So if you can go last part of my presentation, sir. You just cross this, go to maybe last part actually, because I want to just show few projects where you go more. Nearly last part, after smart home project, you just go last portion. Yes, I want to just show few installation. No, you go. I think yes. You go before that, sir? Before 1, 2, 3, 4, I think. Yeah. You can go before, yes. Yes. Sir, these are the, go back, sir. Go back, sir. Back. Yeah. Yes. Next. Yes. Next. From here, sir. Next. Yes. So next slide, sir. Next. So next slide, sir. Yes. So this was our first project. Then this was our second project. Okay. So this is, we designed the smart system here. And you can see that this is, we are implementing there, the smart system. The next one, sir. Next one. And this is at IIT Patna. Complete structure we designed for 200 actually, 200 kilometer per hour wind also speed. So then next, sir. So complete unit we design. You can see that complete unit in solar. You see, this is not the building ground. The complete grounding also we designed this one. And next one is next one. Next one is 1 megawatt distributed solar plant at IIT Patna. And next one is our Toipur. Okay. And next one is Toipur. This is a Toipur village where we supplied 50 houses actually. And this is supply given by, sponsored by General Electric Bangalore and Tata Power. They sponsored this project, and it is IoT-based communication unit with the diesel generator, variable diesel generator unit, and the complete unit we installed, and we completely designed, installed, and also erected. Till today it is working. It is third year, I think, third or fourth year. And then next one is this is the Port Blair. Next one, sir. This is the Port Blair Air Force Station we designed, starting from the cabling and module erection and structure, and then piping, and then the grounding. So you can go after 2 slides. I think there are grounding systems and very complicated grounding. And then we have a small project here at IIT Patna where we integrating, no sir, next sir. So IIT Patna, next slide. This is the microgrid project where our students, they do design many communication units. And then next sir, next. And next one. And our students, they're implementing. Yes. You can see here, we have integrated the one wind turbine horizontal axis, one vertical axis, and one solar, and a controller, and the load. These 4 are integrated together, And this is and now we are connecting another two unit of hydrogen energy, where we are coordinating this one. And then the next, the next, okay, many micro hydro turbine project also we designed. Actually, I implemented also many places. And then thank you very much, sir. I go to later. Thank you very much.
Uh, Thank you so much, sir, for providing such a wonderful talk on the microgrid and covering the smart grid. Any questions from the participants? So you can ask directly.
Sir, if I put my this also, they can send mail also. So no problem.
Okay, sir. Okay. So if any
They
questions,
can,
if anyone can, want to ask, please ask. Otherwise, I will share the sir email ID, and you can drop your queries on sir emails.
sir, you can share the PPT also. If they have any doubt also, they can ask later.
Okay, okay, sure, sir, sure. Thank you so much, sir, for giving your valuable time for this online faculty development program. Uh, Thank you so much, sir.
I am very sorry.
No, sir, no, no.
Yeah.
Okay, sir.
Okay, thank
Thank
you
you.
very much.
Thank you, sir. Thank you.
Cover next lecture. So thank you all the participants. Tomorrow we will start our presentation uh, at 10 a.m. Okay, so it is requested you all to join us at 10 a.m. in the morning. Tomorrow lecture will be given by Professor Rajesh Gupta, MIT Allahabad, and Professor S.P. Singh from IIT Besur, and Dr. Yogesh Singh Chauhan from KNIT Sultan. So that's all for today. Attendance link already I have shared in WhatsApp group, so you can mark your attendance. Thank you for attending.